Okay, this is being column. Okay. So this is a problem. Sometimes the beam is under compression, okay, and some lateral loading. All right, maybe it's better. With a beam with an EI, all right, and sometimes it will under compression. So, and lateral loading, okay. For example, Q, and also an axial force, P. Okay. Because sometimes if this bending rigidity is not too strong, so there's diffraction. This diffraction for this W, and at some point X, and this will be the W at X. And this force, P, will cause some bending moment to the cross-section. You see? So they'll cause some effect. So they take a beam column effect or second moment effect that sometimes we have to consider. Yeah. Yeah. Okay, especially for the EI not very strong, maybe something very small, very soft. So the side diffraction, the axial force will cause some moment effect, right? So that's what we have to consider. Yeah. So let's do this problem. If we have a single lateral force, and this roller here, and under compression P, and we have a Q loading located at the distance C from the left, and the length of the beam is equal to L, right? And we set its X coordinate and the vertical y-axis, and the diffraction we use V, vertical. Okay? So for the first thing, and this is L minus C. So for first case, the X is larger than 0 and smaller than L minus C. I mean the left side of the Q loading. Okay? And in this area, this is a V at X, and we have a P loading, right? And the reaction at here is how much? Is A over C. Q, right? Reaction force. A over C of Q. For any Q, this side will have ratio L over C. The reaction force here, the R2 equal to L minus C over L Q. And the reaction force here will be LCQ. Is that right? For semi support beam. The ratio here is about this here. Moment equal, right? So from this, the internal moment at here, in moment X, so the minus EI, V double prime, is equal to the moment, right? And equal to, and the equilibrium will be what? L over C, P here, okay, equal to minus is plus the moment is L over C Q times X plus PV, right? Or EI, V double prime X equal to minus L over C Q X minus PV. All right? This is the first equation. We take a minus sign to right side. And the second condition is for X larger than L minus C, but smaller than L. Then our deformation will like this. We have it's a cube, right? And this is L over C. Yeah. Okay. For the X here. And another way is to this is Q, right? This L minus C over L. Q. And we have a P here. And the moment is like this. Right? That will be easier. And this is a dx. So the moment here, this moment, is equal to minus EI V double prime. The moment equal to P the Q L minus C over L times the this reaction. This is X minus C. L minus X, sorry. L minus X. Okay? So this is X. L minus X. So times L minus X plus PV. Right? Same thing. We get a EI V double prime is equal to minus Q L minus C L minus X over L minus PV. Okay. So we have two range. Okay. Two type condition. They have to satisfy different governing equation. All right. But anyway, the governing equation will looks like this. This will be V double prime, right, plus P over EI, P over EI, V. Right, equal to minus L over C A QX. Yeah. So this is the type of equation. Here same, it's V double prime plus P over EI. And also EI. P over EI, right? And equal to a V, equal to LEI minus Q, L minus C, L minus X. So I won't say the governing equation will be, it's a second order, but this sign plus sign here. Okay, now let's solve this problem. Okay. Well, my notes they define the problem. Sorry, I should talk this way. Yeah. Okay, so example. Okay. For this being, and he used the actual loading N0. Okay. N0 is P, and here the P loading and is EI. Okay, and this is A, and this is L minus A. All right, and so for this any x is P. Okay, it's A, and this is R1, and this is N0, and for any x, the moment. Okay, the moment will be the formula like this. Sorry. Moment, right? And